a slip circle AB. As we know that the AB is the length of the circular arc that can be calculated from the formula R theta. What I want to focus here on the calculations, because I have found on the some students calculations from previous LA week 9, where you have did some mistakes on the, let's say, the area of the slice, and then the calculations on the theta itself, and finally to calculate the factor of safety. Again, just to just to remind every one of you, let's say we have a slip mass, we have the slip circle, and we have the soil mass above the slip circle as a W. So the one unique W here need to be divided into equal vertical slice, as such as we have W1, we have also here as a W2, and here also let's say we have W3, and the next one is a W4, and the last one is a W5. And then if you remember, there are a few parameters that need to be considered in the calculations. For example, we have here is the slice, and then we have the B, we have H1, we have H2, we have also the area of the slice, and we have W, we have alpha, and the next one we have T is a what we call here is a disturbing force, and the last one we have N is a restoring force. So the T is a result. T is the force that result from the W, which is W sine alpha, and the N is a W cos alpha. So back to these calculations, I hope that every one of you understands how to get the B. B is the width of the slice. If you come from A to this point, that is the B here. And then H, because we assume that the calculations or the slip mass here for each slice is such as a trapezoidal shape. So this is the trapezoidal, and due to this case, W1 is occur at the point of A, so we can say that H1 for slice 1 is equal to 0, whereby for H2 you need to measure using the apple shaped ruler lah, what is the height or the vertical depth. And then from that here we need to find what is the next thing on the calculations, how to get the area, or the next one is the volume of the slice. Okay, let me back here for a second. Okay, we want to find on the W calculations. For example, we need to have the W for 1. What is the W? W is acting at the midst of the slice. For example, W1, if we consider here is a trapezoidal, and the centroid of the trapezoidal that is acting at the half of the W. So this is the locations of the W1. If you assume all the slices in trapezoidal shapes, so we can say that the centroid for W1 is acting half from the B, similarly goes to the W2, W3, W4, and also W5, which is acting half from the B. So B over 2, here also B over 2. And then when you know the locations of the W1x, you can calculate the area of the slice by using the formula of the trapezoidal. It's a half times P times H1 plus H2. So if this first slide has this formula, so this formula is applicable and can be used to all the slices involved here. So all the slices from W1, W2 to W5 need to be calculated with the trapezoidal formula. And the next one is how to determine the W. I think that the W is easy to find it by calculate between the unit weight of the soil times with the area for each slice. And the next one is the alpha. Alpha. Where is the alpha? Alpha is the interslice angle from the O to the W at the base of the slice here. So consider from O and then you point to the W positions here. So if this is your W, then we can have the alpha. Remember again how to find this alpha. You need to use your protector so that you get the angle for this alpha 1 and then alpha 2, alpha 3 until to the last alpha 5. Last class I have mentioned also that this alpha need to be careful on the sign itself, whether you have positive sign or you have the negative sign. Positive sign, if you have the slice is located on the right side of the O, so this is the positive alpha. Whereby if you have the slice that is located on the left side of O, so that is the negative alpha. If the W, for example, W1 here is located on the left side of O, so alpha will be negative alpha, such as negative 1 degree. And then if you locate for the W3, alpha for W3, you may have this one such as, so this alpha is a positive. So you can say, for example, for number 3, slice number 3, you can have positive 5 degree. After you have confirmed all these inputs, then you need to know how to calculate the circular length of the arc AB. As I said again, the LAB is equal to the R theta. For example, R is a known by numbers, and then theta. Let's see.
Naik 3 hari mana naik sir?
Any question? Do you have any question, class? Okay, let's say theta is a 50 degree and then we want to calculate theta in radians. Remember the theta is in radians. So 50 over 180 times with the pi. Okay, why I have to mention this one? Because I have seen few examples from the LA week 9. I'm not sure which one you copy from. And then the formula to calculate the FOS is wrongly taken. So the FOS, if you look at back to the definition, is a ratio between the restoring moment of force over to the disturbing moment. So that when you consider the force in the consider FOS in the force, so you will have that C prime R theta plus tangent phi summation n over to summation T. So this is the case where we ignoring any tensions effect full of water or empty of water. One more thing is that when you calculate the formula of FOS, please make sure that you are using the right one, whether you have the ESA, effective stress analysis, or you have the total stress analysis. Both analyses are being done using the method of slices, because in your syllabus we only covered for method of slices. As you know that we also have method of procedure, but then this is will be not totally assessed in your syllabus. So you have to ensure when you want to calculate FOS, use the right one. I have seen also that you are using wrong formula to get the FOS for this certain case such as ESA or TSA. So please be careful when you read the question. Check, identify what kind of the problems given here and what are the parameters input to be used in the analysis, and then how to start doing the calculations. So the most important is that you have to clear on part of how to draw the slip circle, and then know to get the H1, H2, area, W, alpha, and the last one is the T and N. Okay, do you have any questions on the last week topic, slope stability calculations? So again, how to ensure that your slope design is safe? You will understand, or you will know that by having the final answer FOS. If you have FOS is equal to 1 or more than 1, so we can say that the slope is stable. This is vice versa. If you have the FOS less than 1, so this is unstable slope. So that's and for refresh on the previous recap on the previous topics. So let us move to the our online topic this afternoon. That will be on the last subtopic, which is slope, protections and maintenance. So Muhammad Arifwan, do you get what I have explained just now?
Yes.
Any? Okay. If you don't have any, do you have any problem on the calculations? Have you submitted that one? So just to remind every one of you, our assignment one will be on the next Friday. So again, please make sure that you know what time, when, what topics cover. So you will have enough time to prepare, and then hopefully that will be covered for your um, last test mark. If you fail for test e-test, so that this is the opportunity for you to get the right marks, or to cover your carrying mark. Okay, let us move to the next one on this topic 3, slope protections and maintenance. Okay, as you can see from this topic, it's quite easy to understand because it is not involved with calculations, only theoretical and method of constructions. So what I want you to know is that on the part of the method of constructions, it can be seen, or it can be watched from YouTube, or you can read from any established articles the method of constructions to maintain the slope stability. Or if you have the opportunity to get involved with a company, maintenance company, you can get the idea how to do the maintenance work. Okay, the next one will be on slope protections and maintenance. So this is the learning outcomes that I expect you to have. It is able to describe the slope protections and maintenance. And then this is the same one on the contents, slope protections and maintenance. You will know how many available methods or types of protections for slope and maintenance or repairing work. Okay, we move to the next one here. This is the conditions where when we need the slope protections and maintenance. If you look at to this one, when increase of populations and exploitations of land resources, slope problem has become one of the three global geological disaster, ranking with earthquake and volcano, owing to slope instability, collapse, landslide, and debris flow, brought massive loss for people's life and property. So slope stability problem becomes more and more prominent. So it is involved excavation slope of high-rise building, road slope, railway slope, hydropower engineering slope, and mining engineering slope. So during the engineering construction, slope protections and reinforcement should be strengthened to ensure engineering quality and rate of progress. So these are the five listed how to dealing with the slope protection and maintenance, such as according to the local climatic environment, engineering geology and construction materials, engineering types of comprehensive measures should be adjusted to ensure stability of highway subgrade. So if necessary, slope protective engineering measures should not be cancelled or decreased. So this is the conditions when you decided to do slope protections and maintenance, is that you have to collect all the information from the desk study. Look at to the previous history of this slope itself. For example, the slope has pre-existing slip surface, and then you know the soil properties, soil characteristic, you know the climate of the area you are dealing with, what kind of the weather. So the information is very important before and during and after the constructions of the slope. And the next one, under the poor climate and hydrological condition, as for rock slope or loose slope with silt, fine sand, or easy to be weathered, it should be protected in time after earth and rock construction. As for score protection, generally at sections of small water flow rate or weak flow disruptive effect, paving stone, Pioneer and Pika slab to protect subgrade side slope along the river. So the next one is slope protections. Generally, this doesn't consider lateral pressure of slope stratum. So it depends. It demands protective slope should have enough stability. As for high and steep protective structure, when design and construction, safety facilities should be set to be checked and maintained. So these are the things that you have to look at when you are dealing with the slope protections and maintenance. And as you can see here, these are the available available type for slope protections and maintenance, such as we have unloading, changing geometry, and then the buttressing, structural stabilization, improving drainage, slope reinforcement, soil improvement, and also the next one is the vegetations. Um, these are the things that when we decided to choose which method or which type suitable to our conditions or our problem, our case problem. So we have to look at on the certain thing, for example, on the budget, time, and etc. Um, okay, some some important notes given from one of the lecturer here mentioned regarding to the previous um, recap on the last topic. The lecturer said that if you calculated the FOS more than 5, so please check your calculation. Is it reliable or is it the answer is suitable? And then look at the logical thinking whether the value is correct or not. So I think that as a geotechnical engineer, there's something do and don'ts, or something that we need to bear in mind is that garbage in or garbage out. Whatever input you apply into your calculations, you have to verify it. And then the result must be compared with the other one or from the standard requirement, such as from public work department or any similar case or similar work has been done here. So that's the that's a reminder when you are dealing with the FOS calculations. And as you can see from here, these very simple summarizations on the types or slope protections available that can be made on you, how to repair slope failures, such as we are using the benching, terracing, and then we need to have a proper drainage, and then we also provide retaining wall, and also some cases we need to use the friction piles. I think that the friction piles, as you remember, also being covered in the in the previous topic, chapter 2, foundations, deep foundation and shallow foundations. So the purpose of the foundations is to bear the bearing capacity of the soil, and this is also similar when you are dealing with the slope. Wait a second. Okay, sorry for just now. So when you see on this part here, we can have some sort of the repairing work that can be worked together, such as drainage can become also with the retaining wall and also the friction piles. And then if you want to use as a natural remedial work, we can apply or we can use biotechnical slope stabilizations. And then don't forget to spray shotcrete on the slope face. And also if you are dealing with the weathered rock which having a discontinuity weakness of the bedding plane, so it is recommended to use rock bolts or soil nailing. And the last one is the sheet piling. So this on the right figures indicate to you, we also can use the retaining structure to retain slope from fail, such as you can use the gabion wall, or if you are using the reinforced structure, we can have the reinforced earth. And then we also have the soil nailing. The as I said, when you are dealing with the structural reinforcement, there's a very in terms of the cost is very high, but then it gives to you a high strength instability. So this is the conditions where you have to check on the cost budgeting and also time of the project durations. Okay, the next one is we move to next slides. Okay, let us break a while by enjoying the Kahoot. Okay, please get ready with the Kahoot so we can participate in the online game here. Okay, on the game pin number. Okay, hold on because it's still loading stage. So we are waiting for the loading game pin. So this is only initial assessment on the understanding of this topic. Okay, please join those who have these Kahoot apps. So the game pin is 3896205. Okay, welcome Han. All right. Okay. So there are so many nicknames here. Never mind, because we want to enjoy only. Okay, let it why for everyone on board. Everyone will be on board before we start the game. Okay, there's a nickname here. I love salt. Oh, I hope that you really enjoy this topic. Okay, okay, we wait another 1 minute. 2:25 we will start our Kahoot game. Okay, I think that we have enough players, so let us start our Kahoot game now. Okay, the answer is additional loading. Below our slope protections and maintenance asset. Okay, next one. Okay, the first player in rank is Meow. All right, 773 mark. Next is the true or false questions. Okay, the answer is true. Okay, good. Next question. All right, good. I love soil. Choose the correct answer for soil improvement on the slope maintenance and repairing work. Okay, the answer is lime. So you understand why the answer is lime next after this one. Okay, our top player here is a single player. Okay, I don't know who is it. Who is this one? So next. Okay, vegetation on the slope maintenance. Okay, good. The answer is flatten the slope face, because you know that when we using the vegetations is such as it can improve the view of the site itself as the aesthetic one, and then the erosion protections, and next is allow for the water flowing out. Okay, last questions here. So we still remain with the same player in the first place as a single player. Okay, true and false. Is it true? Okay, what's the answer? Okay, true. Yes, unloading can improve slope protection and maintenance. How to apply this method? Okay, next you will know about this one. So the podium for this online game today is third place, Clayman, and then I Love Soil is second place. So the winner, yes, single player. Congratulations to all of you. Okay, right now we have Roy and I missed the name. However, congratulations and thank you for joining this Kahoot. So it is only some simple short view on your understanding about this topic. So let us go back to our class online just now on the topic 3. Okay, some of the questions that you answered just now is involved with methods for slope repairing. So it can be chose using the simplest one or using the difficult method. Okay, so we go to the first one, the method using the unloading or changing the geometry. So by using this one, you can see that it is involved with the excavation work. You can excavate or reduce the slope height by excavation at the top of the slope, and then you can flatten the slope angle, number 2 here, and the next one you can excavate a bench in upper part of the slope. So the area has to be accessible to construction equipment, disposal site needed for excavated soil. Drainage sometimes incorporated in this method. Okay, the changing of the slope angle from steep slope to gentle slope may increase the stabilization of slope, and the angle is usually supported by grass bonding together with the soil. So this conventional method of angle grading requires some excavations. So this type method does not require heavy load resistance and naturally stabilize the slope with the creepy grass surface. So this very short and simple work dealing with the slope maintenance and protections. So I think that you can see some benches of the slope geometry just purposely to maintain. If you see that the slope can be maintained using the simplest and very less consume money. And the next one, you can see that for the same topic for the same one is that uh, what I want to say is what I have just explained just now. It's just repeating slide only. Okay, the most part here when you see the previous slide, it is suggestions to you the slope angle, the gradient of the slope from the case 1, case 2, and also to the case 3. So it says that when we changing the geometry, you can have from the steep slope into the flattened slope by having these suggestions angles, such as case 1 maybe in the around what we have here is 15 gradients, and then when you have the class 2, you can deal with the 25 gradient, and the last one is a 35 gradient. So this is the classifications of the slope when you opt to for the second methods using the flatten the slope angle. And then if you go next to the second method of the repairing work or the slope maintenance using the buttressing, this is same thing. used for strengthen the slope using the shear key here. So it is over excavate the cut slope and replace the overcut portion with high quality fill. And again, you can see that the shear key or the buttress fill here can be placed along the slope face, or it can be at the toe of the slope face. So the other thing is that, such as you can see that behind the slope face is a very weak soil or weak rock. So when you apply additional structure, or this kind is a buttress fill, so this is improving the soil the slope strength. And then for this next method, using the structural stabilizations. So why we use the structural stabilization is very flexible in a constraint site. I think that if you are dealing with the high-rise building, that you need to construct few meter below the ground surface to form or to have a to have the basement area. So in order to start off the project, we have to excavate a few meter below the ground surface, and then to retain the slope after the excavation, we need to use the structure walls, such as here we can use a drill cast in place vertical piles, or you can use earth and rock anchoring nailing, and the next you can use also retaining wall, and last is a reinforced earth. Sheet pile is another things that you can use also to protect slope from fail. And you can see here, this is example when you have the retaining wall, some sort of the gabion here, you place on in front of the slope face, just to ensure that the slope having a good structure to retain soil behind it to have any movement or disturbance. So the masonry and stone pitching may stabilize the slope to eliminate the failure at the face slope. It is also may reduce rainwater infiltration and prevent slope erosion of the slope forming materials. So these methods also involve rigid slope surface protection, such as shotcrete, masonry, and stone pitching. So the shotcrete is applying mortar on a slope surface by a certain thickness. So if you travel, such as a long time ago when you travel along the express highway, you can see that on the left or right side our view, you can get the slope has been reinforced with structural, and then the outer area has been covered using the shotcrete. So the shotcrete is purposely to prevent any infiltrations of the water through the slope. And the next method that we can use here, improving drainage. Improving drainage, as I mentioned in the early class, it is a method that can come together with the structural reinforcement. For example, here we have two types of the drainage, whether you have the surface drainage or you have the subsurface drainage. So the drainage using the wells and horizontal drains to remove subsurface water. So this is the positions where we place the watering well, and then if you have the horizontal drain. Okay, surface drainage is found in geometrical method. It is used to let surface water flows away from the slope. And then for subsurface drainage, it is found in retaining structure as a weep hole and cut off drain, and used to remove water that already exists in the ground. So that's why it says that for the drainage, when you apply the drainage, or you provide the drainage system, so the chances of building up poor water pressures and saturations of the subsoil can be minimized. It says that. So it means that you can prevent any flows or any failure of the debris. And this very effective method to control the fully saturated of the soil, and the drainage system must be maintained. And it is easy to maintain the surface drain, but it is difficult to maintain the subsoil drains. As I said, the subsoil drains is very difficult to maintain due to the locations of the the subsurface drain, because it is found in retaining structure as a weak hold. And then just imagine how to maintain the subsurface drain. For the surface drain, it's easy to maintain because that you can have the periodical or frequent maintenance by hiring any workers to collect any debris on inside the drain, such as dry leaf or any what we call it, any some sort of paper waste, and then other things that you can see, so you can remove from inside the drain. And then we go to the next method here. If you are using the slope reinforcement. So the slope reinforcement here, for example, geotextile and also the geogrid. So this is a kind of byproduct. I mean that byproduct here is coming from the factory or any sales company that offer to you as a maintenance work for slope protections. So this is one example for reinforce our slope and from any disturbance or from any movement. And what are difference between geotextile and the geogrid? You can see that the what we call here is the scalable of the product itself. Somehow this some kind of honeycomb shape, and then somehow this in a rectangular shape. So whatever shapes come to the slope here, it will give you different strength, because the functions of the product here to reinforce the structure of the slope. So to come up with this kind of the designs, whether geotextile or geogrid, so we need to study on what's the best design to have this shape, or to have this kind of the shape. So the advantages of having this reinforcement, slope reinforcement, such as the scalable, so it is flexible, can be transported and folded, and has a small volume. It can be stretched into a net during construction and filled with materials such as soil, gravel, and concrete to form a structural body with a high strength lateral binding and high rigidity. And also, it offers a strong bearing capacity. The higher lateral binding and anti-skid, anti-change shape, and enhance the bearing capacity of the road bed. So this is involved with some budgeting costs. If you really need to use the geotextile or geogrid, so please be considered the amount on this part. But it's good for road constructions or embankment. And then the next one is the method of the soil improvement. Okay, this is one of questions in our online game just now. So the available method for soil improvement using the chemical stabilization such as cement or lime, and then you can opt using the thermal stabilizations, and the next one is a biostabilization, and the last one natural and electro-osmosis. So the things that you can see here on the uphill slope, so this worker applying or spray some sort of chemical stabilization such as cement. The functions of this cement is that you can see that our soil has been covered with the concrete, so that it will create another additional strength to the slope itself, and also it is prevent from any water infiltration into the slope material. And then the next one, or the last part, using the vegetations, is very simple, but also it can be come together after you having the unloading or changing the geometry of the slope, or using the bearing pile, retaining wall, and then you finally place a root or any vegetation to cover up the process involved. Such as here, let's say you have the slope cut, you have excavate the slope and then you lay on geomembrane, for example, and then lastly, after filling with some fill material, you close the surface using the vegetations. The purpose you are using the vegetations to prevent any erosions to occur, and then it is allow for water to move up from the ground surface, and then it is provide reinforcement to the soil, and the last one as a aesthetic value. That's why when you look at to the final project or of the slope protections, you can see that the final part is by inserting or by using the vegetations. Okay, this is one of the method of slope stabilization and landslide repair before and after. So let us watch how this process involve. Okay. Can you hear that? Can you hear this one?
No, medium.
Can you hear?
No, madam. No.
No, medium.
No.
I try my best to insert the computer volume into the empty, but it's not working on. It's not happen what my expectations. So let me try again for few. Okay. Right. So. Okay, let's go. Never mind lah, if you cannot hear. I'm sure. Okay, this is how the repairing after landslide. Okay, see? Seems like there's no problems after the slope has been repaired. So next, let us move to the next one on this topic. Before, actually, it almost done. So I just want to summarize our class. This. Okay.
And today I would like to share. Hi and Assalamualaikum. My name is Mashita and today I would like to share about slope protection and maintenance based on my understanding. The importance of slope protection and maintenance are the slope protection and reinforcement need to have an optimum strength during construction to ensure engineering quality and rate of process. Besides, slope protection need to be adjusted and not cancel or decrease the engineering geology and construction material, engineering types or comprehensive measure to ensure stability of highway subgrade. Furthermore, Slope protection doesn't consider lateral pressure of slope stratum, so that it should have enough stability. Next, rock slope or lower slope with silt, fine sand are easy to be weathered, especially under poor climate and hydrological condition, so it should be protected in time after earth and rock construction. Other than that is core protection. It happens at section of small water flow rate or weak flow destructive effect, paving stone, pannier and precast slab. So, it protects subgrade side slope along the river. Lastly, for high and steep protective structure, safety facilities should set to check and maintain when design and construction. Next is low failure repair option. First is unloading or changing geometry. We can use an excavation method. The second one is improving drainage. It is to minimize hydrostatic pressure build-up in the slope. It has two types of improving drainage that are surface and subsurface. The third one is slope reinforcement. It has two types that are geotextile and geogrid. The first one is shotcrete. We use mortar or concrete that pneumatically injected at high velocities over a grid of rebars. The next one is terracing or benching. It making slope more manageable by dividing it by retaining walls or friction pile. Other than that is rock bolts. It connects the fractured and weak surface to the stronger rock layers underneath for slope stability. Next is friction piles. It is the piles that are driven into the ground towards load-bearing strata. Next, vegetation. There are four types of vegetation such as erosion protection. Next, soil improvement. There are 5 ways to improve the soil. First, chemical stabilization such as using cement and lime. Second, thermal stabilization. Third, biostabilization. Fourth, natural or byproduct waste stabilization. And last one, electroosmosis. Next, sheet piling. It is the process of overlapping sheet piles driven into the ground to act as retaining walls. Next, structural stabilization. There are 5 types of it. For example, retaining wall. It is the wall that are designed to hold a substantial amount of soil behind it in place, and it is very expensive. And the last one, buttressing. It happens when we over-excavate the cut slope. That's all from me. Thank you.
Okay, so I think that that one is the last content that I want to share with you this afternoon. So, do you have any questions on this afternoon class from the first slide until to the last just now the video? So remember again, our next week will be covered from topic 1 and topic 3. Please make sure that you have prepared well for next Friday. And then, do you have any questions before we end our online class? Okay, I think that every one of you have smart way to study. So, all the best. Good luck to you. Okay. Assalamualaikum. So don't forget to check or to take note what Madam Faiza has mentioned here. Check your FOS value. Is it logic or not logic to get the answer. So when you submit that one, so you will have a very confidence the answer is right. Okay, I see you in the next offline. So I give you as usual for the next following 4 weeks. So please participate the LA from week 11 to the last week 14. So all the best and good luck. to you. I think that these notes can be found from Island, so under the current semester folder. So I think there is no more from me. Okay, Assalamualaikum and have a nice day and stay safe. Okay.
Thank you, madam.
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 Medium nak tanya. Slide medium nak
Madam.
dapat mana?
Okay, if you want this slide, wait a second because I try to. Okay, I have attached here for just now lecture notes, so you can download it and have your own time to go through all of these contents.
Okay, thank you, madam.
Thank you, madam.
Right.
Madam.